Okay, so 7 says, check, this is the one that's similar. G prime is continuous, they tell you up front. So they want the limit as h goes to 0 of 1 over h of the integral of c to the c plus h of g prime of x. And so this would just be g prime of c, okay, using the derivative. So that's what we did with, I think, number 5. So it's just another way, and so see, you can simply do that. You can go, oh, wait. This is just asking for the derivative of g at c, okay? All right, let's go to number 8. Number 8 says you have this function, big F, capital F of x, and they want what it is from 0 to x of f of t, and this is f of t, this function. And so this is like an accumulation table. They just want you to see you're using geometry. So the first thing would be, this one would be the integral from 0 to 0 of f of x. And so that would be f of 0, right? So that's 0. And so what you're doing is you're adding up. So at 1, you would have an area of 1. And then the integral from, so let's go to 2. The integral from 0 to 2 of f of t dt is how much area I have all the way till 2, which is 1 plus the additional 2. So you get 3. And then when I get to 3, I've added 1 more. So 3 plus 1. So let's see what I'm doing each time. This was plus 2. And then this is, okay, now you got to remember to go negative when you go from 3 to 4. So you went down 1. So it was minus 1. And then from 4 to 5, you take away 2 more. And then this little trapezoid is 1.5. So you take away negative 1.5, and you're left with 1/2. So this is just an accumulation table, which shows you, like, if you asked for what 0 to 6 was, it would be negative 1.5. It would be negative 1/2 of f of t dt. And you know how to do this. Okay, I got writing all over this. Let's see. We have this function here, and this is given. It's on your paper, but this is the derivative of a big function. And so that's because it said f of x is 1 to x of f of t, and this was f of t. So this is the derivative, the graph of the derivative. So then you're just supposed to see which is true. So if we pick an x between 4 and 6, so let's just pick an x right here. Okay? True, f of x, so the integral from 1 to, like, say I said 4.3, is going to be greater than 0. And that's true because this area, remember, it's from 1, so we're just talking about starting here. And the area here is much bigger than the area that I picked. And no matter how far you go, if you pick an x all the way over to here to 6, this area is smaller than that area. So this is true. No matter where x is on 4, 6, the area is going to be more positive than negative. All right, so, all right, let me erase all my mess here. Let's look at number 2. If you pick an x between 4 and 5, so we're talking about an x between 4 and 5, then f prime of x, okay, well, we're talking about taking the derivative of that, which is just that. So we're talking about really that f prime of x is f of x. Then that's greater than 0. Well, no, it's not. Any x I pick between 4 and 5, f of x will be negative. So this was true, this one was false. Now this one, number 3, says the second derivative of 6 at 6 is greater than 0. So the second derivative is your concavity, but if you're looking at the first derivative, you're looking for its concavity of the original function, but you're looking at the derivative, and the derivative tells you your concavity is when the derivative is increasing. So this is derivative at 6, it's definitely increasing, and so it would be greater than 0. So Yes, it's increasing, so it is concave up. So that would be a true. All right, I'll stop there.